For A, B, and C, feel free to use exponential notation in your answers down here when you write the prime numbers. Okay, when you write the prime factorization, you can write them using exponents. If there are more than 2 2's, more than 3 2's, you can go ahead and do that. You know, since we're here, I might as well jump on this opportunity to make a key answer. My key answer will be 75. So, if you watch this video, you will put a box around the number 75 and do it as I do. 75, the first number I can think of, which is the lowest prime number, it's probably 3. 3 into 25. Okay, I can multiply 3 into 25. That'll give me 75. And then here, it's not divisible by 2, it's not divisible by 3, nor 4. It is divisible by 5. I can have 5 and 5. And there we go, 5 times 5 is 25. So I would write it down here as 3 times 5 squared. Okay? Some of you, if you might prefer to write it as 3 times 5 times 5. But why do it like this when you know this means the same and you write less? Okay, you have to have this exactly as I did it here with the box around it, with these exact numbers. Remember, it doesn't, 75 doesn't only have 3 and 25 as its factors. You could have put 5 and 15. Okay? You could have chosen a different way, a different route to take. Regardless of the route that you take, your answer will always be the same. They will all have the same prime factorization no matter how you broke it down. Okay, we'll do A and C in class. To answer the questions on page 395, you must have questions 4, A, B, and C from 394 done. The first question is going to ask you which prime factors do 10 and 75 have in common. So now after you've done all the factors for 10, the prime factors, okay, prime factors, and the prime factors for 75, write them out right here. Prime factors, remember, it's only the prime numbers that cannot be broken any further. You want to list those right there. It's really not a list. If you can look at the numbers, you know that 2 and 5 are the prime numbers for 10. Okay? And this is the highest one is 5. This is not divisible by 2, so it's going to have to be 5 because it is divisible by 5. So our answer is simply 5. What is the greatest common factor for 10 and 75? I guess I just answered that. Which prime factors do 75 and 90 have in common? Again, outline which numbers. There are 2 of them here. There are 2. So which one are they? What is the greatest common factor for 75 and 90? Okay, so it's only one number. And which prime factors do 10 and 90 have in common? Again, you're looking for in common and which one is their greatest. So just practicing here. For question number 8, let's read it together. Use the factor trees in problem 4, okay, for A, B, and C, to help you write each fraction below in simplest form. Divide the numerator and denominator by the greatest common factor. Okay, let's see. The greatest common factor for 10 and 75 is 5. Okay, there's no greater factor for 10, and that's the greatest one for 75 as well. So it is 5 here. So let's use that. If we divide 10 over 75, okay, 10 over 75, let's write it again. 10 over 75 divided by their greatest common factor, which is 5, it will give us 2 over 15, which is the simplest form. It is the same fraction. 10 over 75 is the same as 2 over 15. We use the greatest common factor to simplify, to find the simplest form. Use the same here. Use the same greatest common factor to find the simplest form of this fraction as well as this fraction. For question 9, we're going to do the same exercise but simpler. 20, what is the greatest common factor for 20 and 25? Well, they're both divisible by a number, by a number that is to give you a hint, greater than 3. So which number is it? This is divisible by 2, divisible by, not by 3, but it's divisible by 4, it's divisible by 5. This is not divisible by 2, not divisible by 3, not divisible by 4, but it is divisible by 5. So go ahead, figure that one out, and use that same greatest common factor to simplify this fraction. Question 10. Use the space below to draw factor trees. What is the greatest common factor of 1,260 and 1,350? Okay, let's make a couple of prime trees. I'll get you started. 1,260. Well, first thing we need to identify, is it divisible by 2? It is. It is an even number. So let's start like that. We have a 2 on this side, which is my first prime number, and 1,260 divided by 2 would be 630. Okay, I just divided the 60 by 2 and the 12 by 2. 12 divided by 2 is 6. 6 divided by 2 is 30. Okay, can I continue by dividing by 2? Yes, it is an even number. 630 is even, so I have another 2, and I get 315 when I cut them each by half. I cut the 30 in 2, and I get 15, and 6 in 2, I get 3. Continuing. It is no longer an even number, so it's not divisible by 2. So is it divisible by 3? Let's see. If I add them up, 5 plus 1, 6 plus 3 is 9. So it is divisible by 3. So we have 3. 315 divided by 3 would be 105. Okay. And continuing on, is it divisible by 3? Well, let's see. Divisibility rule states that if I add them all together, I must get a number that's divisible by 3. 5 and 1 is 6. 6 is divisible by 3, so it must be divisible by 3. I put the 3 here, and 105 divided by 3 is 35. Okay, and then we have 35. I know that I can get 2 prime numbers out of 35. 5 times 7 is 35. Both those are prime numbers. And there you have it, boys and girls. There is my prime factorization. There it is. Go ahead and try that with the number 1,350 the same way I did. Identify even numbers, use your divisibility rules to solve. And then make sure that you are able to answer the question here. What is the greatest common factor? The greatest common factor right here between the two. I'll give you a hint. In order to find the greatest common factor, pick out which prime numbers they have in common. Okay, this side might only have 1, 2. When you do the prime factorization, there might only be 1, 2, which is the prime number. So take only 1 from this side, and that's in common. You can write the 2 up there. Okay, they might both have 2 3s. This one has 2 3s, and this one will have 2 3s. You can put 3 square at the top here. Okay, and then you have a 5, and this one might have a 5, or this one might have a 7. This one might have 2 7s. Who knows? But remember to only take the one that they have in common and place it up here. Then you multiply all the prime numbers, and that'll give you your highest or your greatest common factor. On page 396, we are going to learn how to use factor trees to find the least common multiple. Please read these steps carefully so that you can see how to find the least common multiple. A multiple is a number that when multiplying, let's say here, as the example has been given to us of 8 and 12, okay? When you're multiplying by 8, let's say 8 times 1 is 8, times 2 is 16, times 3 is 24, times 4 is 32, okay? And when we do it with 12, we'll have 12 times 1 is 12, times 2 is 24, times 3 is 36. these over here are multiples. Okay, and we're looking for the least common multiple, not 8, not 16, okay, but 24. 24 would be our least common multiple, that when we're counting by those numbers, if you count by 8s or you count by 12s, you're going to get that number. That's the least common multiple. And here you're taught how to do it. If you look carefully at step 2 and step 3, right there, it explains that you must cross out the ones they have in common and then keep the rest. So this would be 2 times 2 times 2 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. You can see that right here. And we got the same thing by counting the numbers. Okay, 24 and 24. Make a factor trees. The next one, question 1. You need to make a factor tree and write the prime factorization for each number. 15, 9, and 30. And then you will be asked to find the least common multiple. We'll check those in class, next class, boys and girls. And just for fun, here's a little riddle for you. Which month has 28 days? All of them, of course.